In 1978, the band REO Speedwagon released an album called You Can Tune a Piano, But You Can't Tune a Fish. And in 2014, it was featured on a list of the top 50 worst album titles in history. So, you know, they say you can tune a piano, but you can't tune a fish. Well, for a long time I was saying you can tune a piano, but you can't tune a F-28. But lo and behold, we've had a breakthrough. How about that? Not the easiest thing to tune, because but you can see how sensitive it is. So what did we do to get it working? Well, what didn't I do to get it working? In all seriousness, wow, I did quite a journey this has been, and it's not finished yet. I still have a few more things to do. The lock LED does not come on, so it does not indicate that the PLL is locking in. I don't get a stereo indicator light, although it is very clear you can hear the stereo separation when you tune in a stereo station. So the stereo is working. I think it's just something with the indicator light, and perhaps it's locking also, but just not getting an indicator light. I don't know. The meter is working somewhat. Again, I have to finish that part of the calibration yet. I have a feeling that most of that is in pretty good condition, though, because way early on I was able to feed a 10.7 megahertz signal, multiplex signal, into the IF section, and everything worked flawlessly. All of the problems with this receiver all along has all been in the RF front end and in this horrible nightmare of a synthesizer board. So the synthesizer board has been, by and large, completely rebuilt, and some of the things I've learned about it is that it is extremely picky as to what replacement components you use. Even if you look up a transistor, because you can't get the original anymore, and even if you can get the original one and it's not the exact same manufacturer, or it's a modern reproduction of it or something, you could put that transistor on and it will not oscillate properly in the circuit. So finally I got everything to work. I replaced these two op amps, and I don't believe they were bad, but this thing had a lot of little intermittent problems where it would fade in and out. It couldn't get it to lock in on anything. I finally ended up having to take the logic probe out, and when you adjust this thing, one of the things I learned is this dial scale is not completely accurate all the time. What I mean by that is that the difference between, as you notice, it only goes in 200 kilohertz increments like that. You see, every time the light comes on, I don't know if you can see it in here or not, but it's going on and off, on and off. The problem is the indicator does not always point exactly to the exact frequency that you're tuned to. Behind this, there's that optical encoder bar, and that encoder feeds a signal through these buffer transistors right down here. These transistors will turn on and off into an 8-bit word, which gets fed into this PLL chip, and it's kind of a special one. It's not the kind that it's the same design as ones you see in modern CB radio and other radio equipment, but it's kind of their own take of it, so it's not as common of one. again, as I may have said in the last video, my thanks go out to Mike at Mike's Radio Repair for supplying this chip. He had some of them in stock, brand new old stock, and I sent him an email and he responded right away and said, hey, I got one, I'll send it out to you. So thanks again, Mike. I would have never been able to do this without you. I changed the op amps and put them up on sockets. I did not have the original 4558s in stock, and I didn't feel like ordering them, but I had a whole bunch of LF351s, ACNs, and they're actually a different, I mean, pin for pin, they're the same, they do the same thing. I believe they're a JFET input instead of a transistor input, so they have higher impedance. But I have a bunch of these because there's a specific kind of x-ray machine that we service a lot, and these go bad all the time. It uses them, so I always keep them on hand. So I said, what the heck, I'll throw them in there. They worked fine. Recapped everything. I learned another lesson, and that is that I either need to repair or replace my RF voltmeter. It's not working properly. So I ended up having to use my spectrum analyzer to do some of the alignment because my meter wasn't telling me the truth. It seems like every time I tried to do something on this receiver, something would go wrong. So long story short, everything is working on here now. It is tuning. It seems to be sensitive. There's still, this is a strange circuit in here. What I will tell you, when you're feeding an RF signal into it from the signal generator, if you overload the signal even a little bit, this thing will swamp down and it'll go into some kind of a attenuation mode. It's very strange. So you have to be very careful about the input levels, and even when you read the instructions and follow them and do everything the right way, you still may need to either go up or down a little bit on your signal. Just this thing is very complicated to align properly, but it is now aligned and working. Now, the last part of this is the last video I'm doing on this, because I'll tell you guys, 6 weeks ago, I went in and had surgery for an inguinal hernia. If any of you have ever had that, it's not very fun to have, and you can't lift for 6 weeks, and it's pretty painful for the first 3 or 4 days. But I'll tell you what, I'll go back and have that surgery again before I'll work on another one of these if it's got this problem. Just kidding. But I'll tell you what, that's what I feel like sometimes. But anyhow, tuner is working. We're going to go and finish off this video and get it posted. I'm going to finish going through the rest of the alignment with the multiplex and so forth. See if I can get the locked light to kick in. See if I can get the stereo indicator working. If I get those couple things done, this thing will be completely finished. And even if I don't, I'm getting good stereo sound now. It seems to be relatively sensitive, and the dial is tracking fairly well for what it is. Again, I'm not really sure why they chose to do it this way when they designed this tuner. Really, it was it's not like anything else I've ever worked with. They're trying to make a digital synthesized tuner work off of an analog dial, and instead of turning an encoder like you normally would and using a circuit to select the frequencies with an encoder wheel or something, a knob, it's actually using that linear encoder thing, which is really kind of strange. Why wouldn't you just put a round one on the knob like everybody else? But anyhow, that's the way they did it. So there it is. So let's move forward a little bit here and see if we can continue with our calibration and hopefully get this back to the owner, who has been more than patient in waiting for it and waiting for me. Okay, we're now aligning the IF assembly, and this is kind of what I'm talking about. The instructions tell you to align the dial pointer, set the dial pointer to 98.1 megahertz, and set your frequency meter or your signal generator to 98.1 megahertz. The problem is you don't always know when you're pointing on here what 98.1 is. Just because the dial says it, the little pointer is pointed on the little indicator notch, doesn't mean that the synthesizer is tracking at 98.1. So to be sure, the only way you can be sure is you set it on a channel like this, and as you can hear, I'm getting a nice tone. And then what I have to do is get my logic probe, and I have to look up the actual signal, which is somewhere here on the chart. And if you look, 98.1, pin 8 of the PLL chip is high, then low, 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 high, high, low. So that's what we have to do first of all to verify we're there. So you can see pin 8 needs to be high. I'm doing this around the camera, and it is. And then 9, 10, and 11 are low. So you have 9, 10, and 11 are all low, as you can see. And then 12 and 13 are high, high, and high, and 14 is low. So we are properly set to 98.1 megahertz. So now we can know for sure that the synthesizer, the front end section, and everything is correctly tuned to 98.1. Now we're going to go in and we're going to adjust T8, which is the discriminator coil down here. We're going to set that until we get minimized distortion. So I have my distortion meter, and you can see it's set right here. And I have not tried this yet. You can see it's relatively high. It's almost 4% distortion. So we're going to try to adjust it and see right where we are. And that's the wrong way. Getting better. How about that? Almost like we know what we're doing, huh? Going back up. Okay, so we nulled it out right about there. Right. Ah, I went too far. That's about it right there. Right there. Okay, so 0.2% total harmonic distortion. So that's 0.2. So we're good there. So that was out a little bit, and the null point for the discriminator was out too a little bit, which was the step just before this. All right, now the next step, let me get set up. Okay, the next step is we're going to adjust the signal strength meter, and we're putting a big old 50 millivolt signal into the input of the tuner, and we're going to adjust this pot right here so that our signal strength meter, which you might or might not be able to see with all the glare and everything, is reading maximum. So let me get in here. Going to read that out to maximum. And there it is. So now the meter is now reading properly, as you can see. Okay. And again, this is all important now We're at the part where this has to be very accurate now, because of course this meter reads directly out in micro or dBF, so we have to make sure that this is set properly, and only way to do that is to make sure you have the correct signal going into the tuner. And this is where your impedance matching gets important. I'm using a commercial impedance matcher, low loss, but you can also make a little L network, kind of like this one I use sometimes. It's not super linear, but it will if I use this with my signal generator at 98 megahertz. It's almost no loss, and as I get further away, plus and minus from 98 megahertz, there is a little bit of attenuation because of a little bit of impedance mismatch, but it's not bad. So anyhow, there we go. All right, everybody, there it is. I'm going handheld on the camera so you can see it better. And as you can see, we have our lock and we have our stereo indicator. And I even have a nice little plasma thing going on top of here, just to show that sitting right on top of the RF section. And you can see this thing does not care. Muting is on. It's broke the muting. I have a good station on. I'm on wideband. Meter is working. Let's see.
Spend their time. It's a pre-engineered system.
So she's working. Let's see. There's one. And you can see how it cleans up when you go to narrow IF band. Hear how much hiss? And that quiets it down quite a bit. So, yeah, it's working really good. I'm pretty happy with it. So let's talk a little bit about what we did. There were two main problems with this receiver. Problem number one was one of the lights was out in the encoder sensor. And that's those little lights that are down right in here, you can see. And even though it could tune certain stations, because one of the lights was out, not every encoder slot was being illuminated, so it wouldn't always count the correct frequency when you got up in the upper frequency. So that fixed that. However, this was the big problem. And you can see this synthesizer was a nightmare to fix. And figuring out how it works, all these things was just really difficult. And what I ended up doing is I replaced these two ICs. One of them was actually noisy. That pair of transistors, if you recall in there from the earlier videos, one of them was bad, and you had to replace them both because they had to be perfectly matched, and everything had to be good. It took me a long time to get that. I had a problem getting getting this chip to lock in. It wouldn't, the PLL chip, it just wouldn't encode properly, so I replaced it thanks to Mike from Mike's Radio Repair. And then just a whole lot of adjusting. Now, what got the final part of this working was just a basic alignment on the IF section and on the multiplex section. It really was out. It was just out a little bit. And I can tell you, it doesn't take very much for this to be grossly out of adjustment. So it's very, very touchy. But as you can see, it's working well. again, down here in the basement, very sensitive receiver. And, well, I can't say that I'm sad to see this thing go off the bench. And I think Bella can agree with us. How Bella? How you doing? What you doing? Can you say hi to everybody? Yeah, I know. I'm happy too. You happy? Yeah, that's what I thought. Okay, folks. I know a lot of you were waiting a long time for this video to come out to see if I ever was able to get this repaired or not. But here it is. I didn't get into as much detail on this last video as I did on some of the others, but just wanted to show you we got it done. It's looking good, and I appreciate all that all of you have said and so forth. I've had a few donations again since the last video, and I appreciate all of you. You know who you are. And as always, peace, joy, happiness, and good health in all your lives. I wish you all well. I thank you all for everything, and believe me, there's going to be quite a few videos coming here in the near future, so hang in there. Thanks a lot, guys. Take care. Bye-bye.